Okay, so last week we have applied some 3D models. So we downloaded from the internet, and then we put the 3D models as a GLTF extension file, and then put it into this tag, a GLTF model, or on an entity tag with some component defined as like this. Okay, defined like this. So that was last week work. Now, I'm sorry, and then I continued on the on-demand video to demonstrate how to create or to implement cursor on our application. So let me try to open it on our browser, and I will use Firefox for that. You can use Google Chrome, but you need to remember, if you do not have the VR device, then you need to firstly install RVA-X emulator. It is available for Firefox as plugin and also for Google Chrome plugin. Okay. So in this application, basically we try to implement a custom cursor. Actually, we have played with the cursor before. I think in here. Yes, in the model number 6. But in this module, we simply implement some. It's a default. I believe it's default cursor. Number 6 is about the interaction. So this is the default cursor. Okay, with some fuse interaction in here. We have some mouse, or not fuse, it's a mouse enter basically. Okay, and we use event set to trigger another object to animate, for example, to animate its rotation, its size, etc., according to the event triggered by the cursor. Okay, and in the model number 9, we create a custom cursor. So the way we implement a custom cursor is by defining the cursor itself inside an entity tag. So something like this. So you should use entity instead of a cursor. Instead of a cursor, you should use a entity, and then you define the cursor as the component inside the entity. Okay, and in here you can specify any geometry that you want. I used a box in here, so as you can see, it's actually not rectangle, it's actually the same box as the boxes are behind this cursor. Okay, and then the size is relatively small comparing to the other boxes, and then I put the positions -2. This is to make sure that it won't overlap the cube. So as you can see in here, wait, give me a moment, where is the size? I think the divide size, the box size should be 1. Yeah, 1 unit. Yeah, 1 unit. I think it's 1 unit. So if I set it 0, then it will disappear. Why? Because the cursor is inside the box. Although the effect is still remains the same. So the effect is remain the same. The animation, this kind of animation. So that's why it should be in -2. Something that getting closer, yeah, closer to our view, right? And then now the material is also defined as a component. Okay, and the interaction is defined in here. The animation when it's fused and lift, the mouse lift. Okay, so this is the way we implement custom cursor on our application. For more detail, please visit the on-demand video. And then I move to the project now, or module number 10. In the project number 10, we implemented text component. Okay. The text component actually can be defined simply by using a text, something like this. Okay, I'm sorry. The color is F. Yes, this one. So we can set the value. Value is basically the text that we would like to type, and then the color. Of course, this is the magenta. If you want to change it to other color, for example blue, then you can just modify it as this one, or maybe another color, the cyan, okay, etc. And then we can also modify the position. This is actually the top left of the object. Okay, so if you want to I'm not sure about the length, but you can try maybe -1. So it's a bit, oh no, it's not -1, I think it's 0.5, about approximately. Yeah, it's more centered, etc. And if you want to make sure that it's centered, then you can put it back, move this back to this definition, and then set the align as center. Oh, it doesn't work. I'm sorry. Oh, this one. I'm sorry. Align. Yeah. So this is how it works. So what else? You can also, this is the rep count, is to set how many characters that you would like to include in one line. Or yeah, if you set this as 4, for example, oh, I'm sorry. Wait, 4. Oh, it should be inside the entity then. The negate red count 4. Yeah. Instead, if you want to explore in more detail, actually you can also put it in as a component, something like this. And you can also, so this is the, I think it's Arial or any default very common font used in a web browser. If you want to specify the font using your own font, your defined font, then you can go to, actually there is some font generator for A-frame. Over here, I think, yes, this one, MSDF. You can upload your default, your custom font, and then set what characters that you would like to include on your fonts. So for example, I'll reset this back to its original settings. So for example, this one, I have a custom font named Railway. Railway is it's like the identity, the official font of ITS, and I put it here, okay, as JSON file. So this is how it looks. It's quite messy, but basically the thing that I've done is I upload the font in here, and then I specify the A, B, C, D to Z for the capital and for the small letter, and then the numeric, the number, and also some, no, I didn't specify the symbol. That's why as a result in my text, as you can see on this browser, the dash is gone. Okay, the dash is gone, the hyphen, even though I type it here as a value. That's because I didn't specify the font, where not the font, the characters here. So I didn't, I just, as I remember, I just specify A, B, C, D to Z, and then A, B, C, D until Z, and then the numeric, and then the, that's all, and space. I think actually space doesn't won't count, so you do not need to specify the space. So that's about the text. And then let's move to the mixin. Mixin, in my opinion, is like CSS on web programming, the common web programming. And in here, for example, I have three identical entity in here. Maybe I can delete this one first before. So it's actually the same entity, okay, and then I put some attribute, actually it's a component that's saying it is a box, okay. So I put the box in here. It's a red box actually, okay, it's red, it's a red box, and the idea is flexible. You can define as any, you can use Bahasa if you want, it's okay. And then after I define the red box, I define yet another mixin, but without any geometry, something like this. This is a mixin without any geometry, just a color, okay, just a color. And I put it just like when we type class, right, class to represent some property in CSS. So red box hijau, red box hijau. As a result, the box, I think this one is the one on the center, right? 0, 2, this is on the right, this is on the left. The box on the center and on the left should be green right now. Okay, exactly. And the one on the right is not green, even though we put an ID or a mixin hijau within it. Why? Because the order matters. So if you put the order hijau before the red box, then this color will be altered or replaced by red color, since this mixin defined in the end. So basically the last mixin used on the entity that will replace the previous mixin if they have the same property or the same component inside of it. Okay, so that's the way it works. And then for we can also use mixin to define some animation property or some animation component, something like this. And as a result, this is, if we click it, then it will rotate. Okay, but for other object it won't work. I'm sorry, for the center object it won't rotate because we didn't define the mixin, the spinning mixin. So that's the way mixin works. Again, please check on the on-demand video to see the details. And then the next one is a proxy event. Proxy event is an extra, actually it's not defined on the main frame A-frame library. If you want to use proxy event, you need to include another library called A-frame proxy event component. So this one. And in this demonstration, we would like to collect all the possible animation that we would like to apply on the object. Usually, if we just use an event, for example, there's something like this, I think. Yes, an event set component, we need to specify. I'm sorry, wait, give me a moment. This one, not in here. The cursor, I think. Where was that? Over here. Position. Event set, mostly rotation. Oh, I think we haven't yet implemented that. Okay, so I will need to explain. So in proxy event, before we use a proxy event, actually we can specify all the animation or the effect of our action towards the objects that we have in A-frame application by defining the target for the event set. Actually, we can use event set in here. So we have event set, and then we can specify the event the same, but here we need to specify the rest of the animation definition, something like this one, the animation, the property, etc. in here. Okay, after the two, after this schema, after this, yeah, this is the component, this is the attribute, after these attributes. Okay, but by using proxy event, it will be more tidier. So it's tidier and more practical. Okay, because we will collect, or we will gather all the definition of the animation's effect on its object, on the object itself, all the possible animation in here. Okay, so we define all of this, and then we just simply call the identifier of that animation after the attribute s. and this means that, wait, give me a moment, this is for this one. Okay, so when we click on here, we will have the box moving upward, and if we click in here, we will have the box moving downward. That's because we specify this up definition to the as attribute on this proxy event, and this is for the down. Okay, and actually it will, I think it refers to this one, I'm sorry, not to this identifier, but to the start events value. Okay, and it will reset to its original position if we click on it. Okay, so something like this. And the other thing I would need to explain to you about this look at. This is an extra library as well in here, A-frame look at, applied on this application. So the usage or the benefit of using look at is, as you can see in here, it is applied to the up button, but it is not applied to the down button. You can see in here, down button does not have look at component. So basically this is what happens when you have the look at component. So as you can see in here, the triangle, this triangle follow our camera. So we would not worry about losing its existence, because we will need to click or to fuse on it, right? And if we do not have the look at component, it will happen something like this. The down button may disappear. So that's why it's quite useful, or it is strongly suggested, if we have some maybe buttons on 3D environment, then you need to use these components. And you may notice as well in this application that the first entity, the up button, is like a full definition, fully defined. It's as an integral. So here, because in the down button we would like to have the same triangle but rotated by 180 degree. If we put it as an integral entity, something like this, then we will later have down text, this text flipped vertically. So that's why we need to separate the geometry, the background of this text, into a nested entity and then rotate it respectively. Okay, so this is also something that we can learn and implement. Alright, so that's proxy event. Next one, controller. And for the controller, if you want to play with the controller, this is the time you need to start displaying your RVA-XR emulator. So I will need to inspect element and then open the RVA-XR over here, the RVA-XR emulator, and let's try some emulator in here. By the way, so far actually up to this moment we have learned about some interaction using cursor. Using cursor is actually one type of interaction. However, that kind of interaction is quite limited, so we can only use our gaze, and our properties of the gaze maybe stop at some point or maybe leaving that point, etc. for the interaction. So, and sometimes it's not enough, and we need to apply some other mechanism, some paradigm to interact with our objects in our 3D scenes. One or not one, I think there are several, quite a lot actually, that you can observe and explore. You may check directly on the A-frame documentation. Where is that? The controllers. Yes, the VR controllers. This one. Yes. However, in this VR controller, most of the controllers are specifically designed for some product, some device. For example, in here we have Daydream, Gear VR, Oculus Go, etc. And then we also have some other like Vive controls and Oculus Touch controls. Later in this demonstration, we will rather use a generic solution for the controllers, and we may need to, I think we may need to include these two to make it work. So make sure that you always include these two libraries on your project, on your application, to ensure that you can use the generic type of controllers for your application. We will, on this module, learn about the laser control, hands controls, and the super hands. Okay, so these two types of, and actually there's still a lot in here, I believe. This is the hand control, so you can check on the, again, on the documentation for more details. Maybe I need to explain about this for a bit, about 3DOF controllers and 6DOF controllers. 3DOF controllers mean that you have 3 degrees of freedoms on your control. In this case, you have a 3-axis rotational tracking. So when you use, for example, in here, I think Google Cardboard, Oculus Go, and Samsung Gear VR, you need to have you may only have no, I'm sorry, Oculus Go have another controller, so it doesn't, I think Google Cardboard and Samsung Galaxy S8 only, so these two only have 3 DOFs. So it means that we can only control your camera, even only the camera, to move. I'm sorry, this is about the controller, right? No, not this one. I think the Oculus Go, let me check. Yeah, the Oculus Go, as you can see in here, we can only modify the rotational tracking, so we cannot affect the objects on the 3-dimensional scene that we have on A-frame application via positional tracking. So the positional tracking does not work on the Oculus Go's controller. If you want to apply some 6 DOFs that implement an extra positional, where is that? Yeah, the positional tracking in space, then you may need to use Oculus, oh, HTC 5, because as you can see in here, it has the positional and the rotational. And the Oculus, yeah, Oculus Quest, Oculus, so there is no Oculus Rift. So Oculus Quest or HTC 5, then you can use the 6 DOFs controller set on your application. Okay, so for more detail, again, you need to check on the documentation. Now let me demonstrate this one first. Maybe I will need to command this one. Okay, I will save this. And if you find that your web browser I'm sorry, I need to refresh this first. Okay, if you find that your browser does not show up anything, the controller on the screen, then it's totally fine, it's normal, because basically if we want to enter into some mode that we can use the WebXR controller on it, we need to activate the VR feature, okay, on the bottom right of your browser page. And then to control this controller on the screen, then you may need to modify the emulator on your right side or on the bottom side of your screen. It depends on your layout or on your configuration, the layout configuration. And maybe you have view something like this, and sometimes it's bothering. So we prefer to have a single view, even though this is a VR application. You can opt off or turn off the stereo effect in here to have this kind of layout or view configuration. Okay, now I would like to apply the 6 DOF using the Oculus Quest. Since I defined this laser control using right hand, then I can only use the right controller over here to control this one, this object. For example, I would like to move it left and right, something like this, okay, or up and down, okay, or in X and Y axis, something like this, right, or on Z position. Okay, you get the idea. Now if we want to point the laser to the box, then we need to make sure, maybe I need to move the head mounted display about a bit to the right, something like this, and rotate it maybe the something like this, so it's more observable, okay. Then I click on the controller again and try to rotate by Z axis, something like this, and then rotate it by, what is this, the X axis, I think. Yes. So if you, as you can see in here, if the case was the laser does not go through the object, it means that it selects the object already. Then in this case, I can, for example, squish the button. Squish the button means that you, where's my Oculus? Oh, behind the screen, I'm sorry. So we can have some like a grip action. So if you have the Oculus Touch, you may check there is some button under your middle finger. Okay, usually it's under middle finger, or you can also use your index finger. When you press this button, okay, it means that you squeeze it, something like this. Okay, squeeze it. And when you squeeze it and release it, it means that you click on that buttons, on that object. and that's what has been applied in here. So we apply some simple animation to rotate the object, to rotate 360 degree by X and Y axis after the click. Okay, so that's how it works. So that's laser control. And now let's try to implement the next one, the other one. This is super hand. Do we have our hand? Why the hand is not here? Wait, something wrong. Oh, I'm sorry. I always forget. Please turn on your VR, and then you got your hand in here. Basically, this hand is the same controller that you have. So, oh no, this is camera. Okay, this is the object. This is the where's the controller? Okay, this one. I need to move it. Oh gosh. Okay, I think this one. Oh no. Okay, this one. I can move it. Okay. Okay. Wait. It should be this way. Yeah. I think we are inside the box now. Then I squeeze it and move it to some other position, and as you can see in here, the box are moving and rotating. Okay, and use that hands as its origin. Okay, so that's the function of the super hand. So if the case for laser, we need to like using some kind of ray tracer, point the object from distance and then shoot at the object and control it. But if we use the hand controls, means that we need to directly touch, in quote, the objects and then have some interaction with it. And the super hands is an extra, super hands A-frame is an extra library. You need to check their documentation in here to understand better about the possibility that we can apply. Where's that? Give me a moment. Yeah, the reaction components are specified in here. Okay, reactions components. And the one that we apply lately is grabbable. Okay, and you can implement other type of reaction components by reading the documentation on this GitHub. A-frame super hands. Just Google it. Alright, now I need to reset. How to reset this? Reset pose. Okay. Now I'm back to my original position. And that's all for the controller. Now, let's continue to the scripting. Okay. For the scripting, we need to create basically it's an extra how to mention that. Oh yeah, maybe I can start by explaining this. So A-frame was built on the top of 3GS. So if we want to modify the functions or the components in advance, then we need to go to the JavaScript and implement some of things that is basically not covered or not given or provided by the A-frame library itself, then we need to go deeper into the Three.js library to make it happen. Right, so in this module we will learn about the basic of scripting, how to implement scripting on the A-frame. To make it happen, you need to make sure that we need to check what is the result, the temporary result of these files. Scripting. So this is the object that we have. Maybe I will need to close this for a while. I can use my, if you do not know how to rotate this, you can use AS, W, and D, or your arrow direction key to move forward, backward, leftward, and rightward. And if you want to rotate your camera orientation, you can use your mouse. Okay. Okay, we have a box with a red color. Now let's have some script. Here we need to specify the text script as usual when we create a JavaScript. And if we want to specify some components, custom components inside some entity, for example this one, I have a components called foo. So in this case I will register new components in A-frame by doing this. A-frame.register components and specify the ID foo, something like this for example, and then define the function in here, the closure or the function in here. And if we take a look on the register components, we may see in here that we need to specify the schema, the init, update, tick, remove, pause, and play. This is some attributes that we can, or properties from this class, from this abstract, that we can play with. And for now, let's try to start with the init. Okay, so we specify the init. In here let's call the init function, define the init function by doing this way. It's like the JSON definition, right? So we have a function, and then let's just make a simple function to console.log, something like this. And maybe I will use like CSS based console log. Fonts, yeah, 2em. Yeah. So let's take a look what we got. Oh, I'm sorry, this is register component without s. So here we go, we got hello in here. Okay, so we get hello. It is triggered because this entity, once it is built on this application, then it will call the hello console on the init function. Okay, if we set the box with the same foo, then we have a to hello, right? There 2 times in here, you can see. Okay, 2 times. All right. Okay, now let's try to maybe create some specific, for example, wait, okay, maybe we can have two foo. Okay, define in here, so we can have two already. Now let's try to set our components to have some attributes defined, something like this. Okay, ID is actually the same as foo. This is a component. Material position is component. Some components may have a single attribute, something like this, for example. Or actually ID is not a component, it's a, maybe yes, yeah, it is a component. Or the single value can be simple string like this, or maybe with some implicit array values, yeah, something like this. But later in the end you need to parse your value in here inside your init function, within your init function. And some components may have multiple attributes, something like this. Material can be defined as a color, and then maybe you still remember that it can be it also have a wireframe attribute that can be set to true, for example. Okay, so actually we can also do the same for our new component by defining the schema. Okay, so we have a schema in here. Schema is basically the way we specify the attributes for our component. I will give you some example in here. So we need to set the schema something like this, comma in here. For example, we have message, for example. Oh wait, data. If we have some data, yeah, maybe some message. Let's call it message, and then within this attribute we will just make it single for the first time for now. This type is string. Okay, and then I'm sorry, it should be in a lowercase. And the default value, we need to specify the default value. The default value, for example, is foo. Okay, now let's set the init as maybe plus this message. I'm sorry, this data.message, something like this. Okay, so we have two hello foo, I think. Yeah, two hello foo. But now let's try to specify this foo on the box, inside the box, with some properties. For example, is box. Then we have I'm sorry, the message is with, oh wait, oh I'm sorry, if we only have a single attribute, we just simply do it this way. Yeah, I think this way. Yeah, I think this way. And then this should be just this data. Yeah, hello foo and hello box. Okay, this is when we try to implement single attribute on our component. So maybe I'll just push it this to. All right, component with a single attribute. Now if we want to have a multiple attribute, then we need to just like something that you see just lately. So we need to specify the name of the message. For example, message 1 with this kind of definition, and then message 2 with this kind of definition, the same. Maybe hola. So this is gonna be message 1 and another space. This data dot message 2, and let's specify the message 1 in here as a box. Okay, and maybe the entity we specify the message 2 as good morning, something like this. Then this is what we have. Hey, I'm sorry, there's something wrong in here then. Oh, we cannot do it this way, unfortunately. It will break. Oh, I'm sorry, this one. Yeah, hello Fu, good morning. Or maybe with something like this. Hello Fu, hello box, good hola. So that's the way we use the multiple attributes on scripting. Yeah. So I think I need to push it upward first. Multiple attributes on custom component. Okay, now let's check what else that we can learn. Okay, we may use some method in iframe called get attribute and set attribute. So if we want to modify the attribute of the A-frames object, we cannot we are not suggested or recommended to alter it directly on it's actually not possible directly on the tag. Instead, we should use this mechanism inside the register component to apply for that. Right, so for example, now let's try to have let's have 2 boxes. Maybe I'm just gonna delete this. Let's try to have 2 boxes. The first box is just full. Box 1 is a color red without wireframe, and let me put it on the left, a bit on the left. And then for the second box, I will just use this. Maybe the message 2 is adios. And then this one is box number 2, and let me set it green with wireframe and put it on the right. So this is so far that we have. Okay, so we have these 2 objects on our screen. Now let's apply some default cursor, a camera, a cursor. Okay, so we have this cursor now. Okay, this cursor. Now we learn about this data message and data message too. Okay, so it works, and I believe that you have understood. Now let's try to log another thing. In this case, we would like to learn about this. So inside the, where is this register? Give me a moment. So in it, yeah, this is the things that we can read inside the component prototype properties, the init, update, remove, tick, talk, pause, place, and update schema. So this data, this EL, scene EL, etc. So you can check in here later, okay, on the A-frame documentation. So for example, we would like to read the entity as a whole. So this is what we have, this EL. As a result, we got the full specification of this object, okay, for both objects, right? So that's when we try to console log the .el. Now, I'm sorry, maybe we need to take a break because there's adhan outside, so maybe break for 2 minutes. Alright, let's continue. Another way, we can also specify or try to check the log of some objects directly through the query selector. For example, let's define some box and get it through the query selector. Something like this. We have a box 1 and box 2, right? So let's get the box 1 and then console.log this box. As a result, I believe that we can get the similar, oh, pardon me, yeah, but for now it's always box 1. Okay, it's all box 1, even though we call the definition should be box 2 in here, right? But since we are using query selector, then we can we only get the definition from the box 1 only, right? Now we can also have some, for example, let me comment this one, add event listener. So the event listener is actually belongs to DOM, DOM. So in this case, we need to get it from this element, okay, from this element, the entity of the HTML element. So in this case, this EL already includes add event listener, so we can use it here, event listener. For example, let's apply some click event and with some function. If it is clicked, then console.log clicked, maybe. Let's give it color, blue. Right. So when I click it, it's become blue. Okay. Sorry, this is size. Click, clicked. Okay. So it works. So this event listener it works. Now, what if we want to click some object, then try to set the attributes of that object to other properties? To make it happen, we cannot use for example these I'm sorry, maybe we need to check this one. Yeah, we need to test this one. Okay, we need to test this one first to show you that it doesn't work. It doesn't work. Why? Oh, it works. Oh gosh, wait. Oh yeah, it still works. ADS hola hello books. So this data still works. Right. This is referred to this one. This is message from the Fox. Okay, so basically it still works. But if we try to console, for example, let's try to control log these. No, I think it's okay. Now it's okay. Okay, maybe we can neglect this one. We can neglect this one. So this works pretty well. Now let's have a look on this add event listener. Actually, it has some parameters called event. Or actually, we can also use EV. You can use event, you can use EV, but you should use the same word on your codes inside. Okay. For example, I'm using EV. Okay. In here, I can check the, like for example, EV dot source element. EV.source element is actually the same thing as this element, I think. And then set the attribute. We can try to check the set the attribute. So let's change the foo into some other alternative message. Okay, some message, something like this. And at the first time, okay, at the first time, oh, I'm sorry, yeah, at the first time, oh gosh, okay, I'm sorry, we should test this first. That previously didn't appear because we haven't yet clicked on the object. Okay, so this is the moment before I click the object, and now when I click on the object, it is error. There is some error about undefinition in here. This data is undefined. Okay, because the program confused. It confused what is this, because it can be this. Okay, it can be this, it can be this, it can be this as a whole. Okay, so in this case, if we want to get the data, then we need to create a proxy variable in here. For example, let data is equal to this data. In this manner, we can just simply call data for later. So in this case, if we check in here and we click on the object, it works now. Okay, it works. Right. Using the same mechanism, same understanding, we then try to set an attribute in here. Give me a moment. Before moving into that, I will need to demonstrate this one. So when I click in here, it doesn't work. Wait, the set attribute message 1 to alternative. Ah, yeah, because we need to prove it by calling the same data once more in here. So let's have a check. Click. Yeah, it changed right now. This one as well, same. Alright, so it does work. So we can just leave it now. Now we try to, for example, maybe we can play with some other attribute. This is not really fun. Let's try to, for example, change the position. Okay, source element dot set attribute of position. Wait. So we need, maybe for example, let's put it on the center right now. So set the position as 0, 0, 0. Okay, let's do it this way. Okay, I think it works. Click. Oh gosh, it disappeared. Wait. Position is 0, 0, 0 is in the camera. I'm sorry for that. So let's say -2. Okay, over here. Oh, what was that? Oh, -3. Okay, so to make it equal, let's make it -3. So when I click the object, it moved to the center and exactly on the center with the depth of 3. So that's when I click on the object. Okay. You can also get the attribute actually. So this is set the attribute. You can also get the attribute. With the same logic. So it's what things that you would like to take, but without any extra parameters, just like this. So in this case, you can you got the, maybe you can save it on some variable. Let clicked data. Okay, console.log. Let's check the click data in here. Okay, we got some position in here, right? -2, 1.5, -3. So instead of using some static chains or static alternate actions like this, we can maybe, for example, try to move the or translate the object upward, just on the upward direction. In that case, then we need to do it this way. Then the click data X is the same, and then plus give me a moment. Then it should be like this, plus click dot data click data dot y plus for example maybe increment by 0.5, and then the z will be, oh, maybe I need to put it on the different line so you can see it clearly. This is the X, this is the Y, and this is the Z. Click data.z, something like this. So once we clicked it, we will move it upward for any object that we click, something like this. Click it again, click it again, click it again, and so on. Click it, click it, click it. So that's the way we play with the attribute. Okay, so let's wrap it up. Maybe I'm just gonna push it upward to GitHub. So this one is get attribute and set attribute. So this is the way it works. Now let's move to the other function, the update function, this one. So in here we can add another function to represent the update event, and it may contain the old data, so you can also track back the old data before. I think it has some old data and new data, if I'm not mistaken. Or yeah, the new data is actually the same with the attribute. So when you have an update, when you update your attribute, for example, using get attribute or set attribute, the A-frame will still record the legacy data right before. Okay, so this one is updated. So as you can see, let's check this. Actually, yeah, once the init was triggered, it actually triggers the, or affects or calls the update function as well. So this init, when it's basically when the object is firstly initialized, then it will also call the update as in addition to init. Okay, and then when we try to, for example, update this position, wait, why it's not updated? Why it's not updated? Give me a moment. So this one is do I made something wrong here? This is this one, right? The click data, we do not need this anymore. We set the attribute, we change the attribute. It weirds, it's weird. Late data, this data. Oh, it only occurs for the data that we specify on the schema. So if we change the position, then it will not affect the update function. So for example, let's turn this on. Okay, let's turn this on. Okay, so we try to change the message one attribute on the entity. Then when we click it, it will trigger the updated function, okay, for both objects. Okay, so I think, yeah, that's the update. I think, yeah, it depends on your case. It may vary, the implementation may vary. You can play with it later. Now the next one is tick. Tick is some function that will be called periodically and incrementally by the clock of our processor. So it's more like it will tie up to the, I think, to the frame per second. So it depends on if the application that we have uses 30 frames per second, then the tick will be called every 1/30 seconds. Okay, so, and in here actually we can have some there's some optional parameters, which is, maybe I can just type it as a comment in here. So the time and time delta, we can specify this. Otherwise we will just simply using the default clock, the default interval defined by the frame rate per second. And we can utilize this function as the motor for animation. For example, maybe you can apply something like this al get object 3D. We try to find the mesh inside this element. This element is actually the entity, right? The elements is the entity. Where was that? This one. This element is actually this entity. Okay, this entity. And inside this entity, I think we have object 3D. Somewhere here. Why it takes time to check it, or maybe you can check it on here. So the get object 3D, this one. This is a property that can be used from element, okay, any entity that we have. Okay, like for example, let's try to play with the, actually it can be mesh, it can be, for example, light, it can be mesh, it can be light, or any other 3D object. Yeah, it can be light as well, as you can see in here. But for now, let's just play with the mesh. Let's try to rotate it maybe by 0.05 degree for every, I think it's not, yeah, I think it's degree for every frame rate. It doesn't work. Tick. Give me a moment. It's a rotation plus. Wait, why it doesn't this rotation, this gap object 3D rotation Y. Maybe let's check it again later. Let's try to experiment with other. Maybe let's try to put it here. Test the get object 3D in here first. Get object 3D mesh. Let's manipulate the material. Change the color into another color. For example, yellow. Something like this. And let's check it out. Okay, it works. It actually works, but now the rotation doesn't work. I'm not quite sure why it doesn't work. let me console.log. Tick. Yeah, it's calls every time. So it should work. Oh gosh, this is so wrong. It should be like this. Right. Okay, so I forgot to put the equal. Okay, so this is the update and tick. So I'm just gonna put it here, update and tick. What else from the, maybe we can also try to let's see. Let's wait. Okay, I think this one is enough. Maybe we can move to the next file now. Oh, it's already almost 12 o'clock. I'm sorry. Hopefully we can have enough time to finish all of this. Let's continue with the custom primitive. Okay, custom primitive. Right. Now we have an entity with some components called kotak kosong inside the scene, and with some position. X is on the centers, a bit on the top, a bit upward, and deep to the camera, deep to the scene. Sorry. And then in here, it basically doesn't have any geometry. We would like to specify the geometry inside our script as a new component called kotak kosong, and that's gonna be our custom primitive. Okay, it may give you some idea. Maybe later you will need to create some symbol. Okay, symbol that the instance can be used anywhere on your text. Maybe you just need to let's say define one single tree as a symbol or as a components in here, and then later you can duplicate or instantiate the components on any place inside the A scene by calling that component. Okay, so you can have multiple trees with the same definition as a custom primitive. Okay, so as the before, we need to call register component, something like this, and it's called kotak kosong. Okay, or maybe just change it. No, yeah, okay, just use kotak kosong. And then the schema will be, it has some ukuran. Okay, ukuran. The type is number, and the default is 1. This is the ukuran. And then the tick. Maybe try to rotate that. Wait, this is kotak kosong. Or maybe just forget about the tick first. Maybe let's move to the key method, which is in it. So the most important one, function. And then let's define, for example, let's save this schema into as a data in here. Okay, something like this, and then specify this. Maybe we have a material. Let's call it bahan, and got it from the 3GS definition as a mesh standard material. and we may need to specify the property of this material. Maybe the color is for example red. Oh no, maybe try yellow. Okay, or maybe magenta. Let's call it magenta, and then set it as a wireframe. Okay, make it 2 lines. Okay, and what next? We have the material now. Let's define the geometry. Oh, maybe no, bangun is a geometry, right? Geometry. The geometry is new 3 box geometry. Yeah, box geometry with some, for example, the size will be, I'm sorry, I think for the box geometry we can just simply type in here as a parameter data.ukuran, okay, and 3 times for x, y, and z, and then let me check. Width, height, depth, with segments, height segments, and depth segments. Let's maybe to make it a bit detailed, because it's wireframe, let's try to make it 5 or maybe just 3. 3 I think is okay. So this is the geometry, and then this is the kotak. New wait, this is kotak. Wait, this is geometry. Kotak. Yeah, maybe just geometry is okay. This is kotak, and then the kotak itself is mesh, I think. Yeah, mesh, combining this bahan and this geometry. Alright, I think it's all good to go, and then we call this el dot set object 3D. So we have get object 3D from the previous module. Now we have a set object 3D, and we specify the mesh for that object. This kotak. Let's see whether it works or not. This one is number 15, custom primitive. Oh, without dash. E is undefined. Wait, this is some error. The schema. The schema is fine. Kotak kosong 3. Is it because this is common? I think no. Wait, what's the problem? Oh, really? No, I don't think so. Is this because of this? Oh. Okay, so the problem is here. Guys, if you have any idea what's wrong with this code, you may tell me as well. So it may take some time to inspect. The problem is in here. Oh, this one is undefined. Why? Oh gosh, this is so wrong. It should be geometry first and then the materials. I think this is the error, hopefully. Yeah. Okay, I'm sorry, I put it in a wrong order. So the mesh parameters should be geometry first and then the material. Now we have this object already. Okay, so this is our custom object. But maybe you are wondering why should bother with by working on this custom component if we can just simply using a box for this matter. Yeah, you are right. But if the case, as I mentioned previously, you may have some complex object that would be defined as a symbol or component, then later you can just simply instantiate it to duplicate the object, then you will need the custom component. Now for example, maybe we can try to create an object that contains two geometry altogether. Okay. Maybe I'm just gonna create this as a bahan kotak, geometry kotak, and okay, something like this. And then let's create another object. For example, this bahan, maybe for the bahan is the same. Let's use the same material, but for geometry, let's use something like this. For example, 3 torus, buffer geometry, and then let's specify something like this. Segment, and the stride is 45. I think this one is good to go, and then the next one will be okay, the geometry is ready, the box is ready. Yeah, now let's create the mesh. This donut, a new 3 mesh containing geometry donut and this bahan, just only bahan in here. Okay, so we have 2 objects. Now let's group it. Let's group these 2 objects. Let's create a group, new gabungan atau kotak donat. Kotak donat is a new 3 group, yeah, and then this kotak donut is consists of this kotak and this donut. Alright, done. Oh gosh, another error. Geometry donut is not defined. Geometry donut is not defined. Oh, I'm sorry. This. Wait. Oh gosh, this kotak donut. Okay, tada. Okay, good. So we got this geometry. Now for example, let's move it. Let's try to make it more cool by, for example, put some tick now. Tick. So we have a tick function. Function in here. Let's create some animation on the box kotak. Yeah, on the kotak. Rotate it on the y axis by 0.1. Yeah, this is quite cool. So this is our just a single. This is one component that we can basically. You can duplicate it as many as you want and just set the position in the different location, and then you can have exactly the same. And you may alter if you want. You can define some extra method inside the init for maybe defining the color, defining the size, or defining some other attributes necessary. Okay, so that is the custom primitive. Okay, now what time is it now? 12:06. Now let's move to the locomotion. Locomotion is the way we move our camera inside our 3D objects. And for that, on our 3D scene, I'm sorry. And for that matters, let's see. I will demonstrate some. Okay, for example, let's have a check what object that we have in here. Number 16 is locomotion. Okay, we have a 3 circle on the floor. Okay, 3 circle on the floor. Right, and it has a different position, different X, but the same Y and Z. We need to rotate it because if we do not rotate it, it's gonna be like this, right? So it should be this way to make it like attached on the floor. All right, now let's try by, okay, maybe we can start with the building an entity now. So we need to have an entity that will help us to locomote, to move our camera inside the environment. Okay, and for that case we need to define, actually we want to move our camera, right? We want to move our camera. Actually we have a camera and cursor later inside this application, but now this camera and cursor should be reside, they should reside or sit on or sit inside an entity, because this entity will also help both things, the camera and the cursor, to move within the environment. Okay, so this A entity, okay, will have a nested entity called a camera, and the camera will have a yet another nested entity called a cursor. Okay, something like this. Let's take a look. So this is what we have now. Okay, now let's for example, maybe you think, why don't just simply move the camera instead of having an entity, extra entity out of the camera? Maybe we can, for firstly we can try to demonstrate when the locomotion is applied to the camera. For example, let's have maybe we need to check the A-frame locomotion. I think it's inside the A-frame extras. Should be inside the A-frame extras. Yeah, over here. Yeah, there are some controls locomotion in here that we can use: keyboard, mouse, touch, trackpad, gamepad, movement, and checkpoint. Basically, for this movement and checkpoint, we will utilize the cursor, simply using the cursor that we have. So it's gonna be a very generic. We can apply it to any VR devices, because the simplest VR device yet still have a possibility to implement the cursor. Okay, this is for the documentation. You can check in here. Like for example, we would like to okay, let's do this one first. Okay, so over here let's have some movement controls, and the controls that we choose is checkpoint. It actually can be keyboard, touch, gamepad, trackpad. You can replace this one. If you want to use gamepad, just replace with a gamepad. If you want to use a keyboard, then just replace with the keyboard, etc. Okay, basically that's to move this one. So if you have this VR mode inactive, you can use your keyboard to move your camera, right? But if you are inside the VR, then you do not have any way to control. I pressed the keyboard already to control your camera to move, and also your mouse. That's why you need to implement these movement controls inside the VR as necessary. And then for today's example, for now, current example, we will to use the checkpoint, and then we need to specify the checkpoint type, I think. Checkpoint controls, and set the mode to, there are two types of mode. The, I think, animate and teleport. Animate and teleport. It's not here, unfortunately. It should be somewhere. Alright, you can Google it actually. Right, so like for example, we just use teleport for now. Teleport, something like this. In this case, then let's have a look. So if we press on here, so it doesn't trigger anything because we haven't yet defined the function. Maybe, oh no, it should apply to, oh yeah, we need to apply the checkpoint components in here. Checkpoint on every object. Okay, maybe let's try to not apply on the most right object in here, so just apply it on the left and on the center. Let's have a try. Left. Okay, we move to exactly inside the circle. Actually, that's what happened. So we cannot see anything. This is bad. So to solve this issue, we need to put some, I think, offset. We should put some offset in here. Some, maybe this is the centered, right? Yeah, I think this is one is the centered. Let's put some attribute, the offset equal to, like for example, the X offset is 0, the Y offset is 0.5, and Z for the 0. So like for example, if I click on the red, then I'm about 0.5 above the red circle. But if I click on the left, so I'm exactly inside the circle. So it works. So I think we need to set it higher. Okay. Let's make it the same, something like this. So if we move to the, for example, over here, so we are above the circle, so it's safe. We move here, it's above the circle, but then we cannot click this because we haven't yet defined the checkpoint for the right circle. Okay, now maybe this kind of offset will be good if we have, for example, some specific object. Maybe we want to move to the front of to the front of a television, maybe. So it should be better if we teleport to some place on that object, on that television, with some offset in x-axis, for example, or z-axis, right? For example, maybe I want to just, if I want to go to the green one, no, this is the green one is over here, to the green one, then I just want to move maybe a bit leftward, so minus 1.5. So like for example, I'll go to the red, it should be right on the top of the red. If I go to the yellow, then I'm about on the left side of the yellow. Maybe you have some object in here and we do not want the user to teleport exactly on the object, then we need the offset. Okay, but somehow for this case, actually we would like to move on the top of the circle for the whole case. In this case, okay, in this matter, as I told you, then we need to just move this definition on the entity instead of on the camera. Okay, so we do not necessarily, or maybe we can test now. I will just remove for the center one. Okay, I'm sorry, something like this, and here we go. If I go to here, then I will be on the top of, oh, very high, it's a very high, but in here is lower than the before, because for the yellow, let's check on here. Yes, after we have a 1.5, give me a moment, this one is 1.5, right? Yeah, but the checkpoint, wait. Yeah, actually if we use the camera, if we put it inside the entity, this one, if we put it inside the entity, the position, the Y camera position will not move. So that's why if we do not have an offset, for example for this center circle, we are exactly on the top, the same, actually on the same height, okay, on the same height. But if we press on the yellow, we move higher than before because we have an extra offset in here. Okay, so that's why for this case actually we do not need to have an offset, because we just maintain the camera height position. Okay, so I'm just gonna put it here, here, and here. Okay, done. Now this is the checkpoint teleport. Somehow this mechanism may create nausea or give some headache, some motion sickness to the user. In that case, oh, maybe not, maybe even not, maybe that's but the users may lose some sense of direction by using this teleport. Okay, so maybe we can try to use another type of checkpoint controls, but before that please allow me to push it upward to the GitHub. So this one is a teleport. We just simply change this one to animate. Okay, and this is the result. So we move to that position with some transition, linear transition. Okay, in a, I think this exact same philosophy for all teleportation. Okay, so this is the way we locomote our camera or ourselves inside the VR using the movement controls, the checkpoint controls. And okay, maybe we can specify the speed, and by using animate speed, something like this, maybe 5. Let's make it faster. Okay, this is faster than before, but please do remember that it may have some risk, give some nausea or motion sickness to the user if you make it fast, your movement fast. So bear in mind that you need to set this in appropriate value. Right, and last thing about the locomotion, we can also implement some yeah, we need to maybe we can implement some event listener as well in here. I think it will be very useful for you. For navigation start and navigation end, well, we may create some function. For navigation start and navigation end, console.log, just momentarily we just gonna use this start and end. Font size .2am, right, and this one is color green. All right, now this is for the end, the other one for the end. Let's make it red. All right, let's have a look on the console. Yes, of course, it doesn't apply because we haven't yet connected. So in this case, we need to have this navlog attached to the entity, this one. Okay. Let's try it once more. Yes, it works. So later you can have something on here. It depends on your mechanics, on your purpose, on that's gonna be a very different from one project to another. Okay, so this is locomotion, guys. We're just gonna put in here animate the locomotion and lock it, maybe. Yeah. Okay, now we move to the next one. Maybe for the sound, it's actually not really it's not necessary to apply the sound to your application later. It's not, but okay, maybe I'm just gonna copy and paste my code from my snippet and explain it to you, because I would like to explain more about the physics. This is more important. Let me copy and paste. So for the scene, we have a camera raycaster, so let's have a look. This is the module number 17, sound.html. Wow. Okay, I think we need to just I'm sorry. It seems that my Visual Studio Code got some error. Give me a moment. Alright, I need to refresh the live share URL. I'm just gonna edit this one, and please check on the new one to join my session. Now for the sound, oh gosh, again. I think there's some problem with my internet connection. Okay, now let's have a check. Maybe I'm just gonna finish this first. I'm just gonna copy and paste my snippet. So we need to have a components in here called sound controller. So we would like to have these three objects as sound controller: the play, resume, and stop, to stop the sound. And then this one is to it will become the speaker for the object. And then let's have a look. And to apply some music or some sound to your project, you just need to specify the attribute of this component, it's called sound, with some source, and it's located in here. The sounds, I'm sorry, it's not yet here, so I need to put it there. Where's the sound? Okay, over here. Which one? The cartoon. So maybe I'm just gonna copy this and create a new. It may cost some storage. Audio. Okay, and maybe an extra models. Oh, I got it already, the island in here already, so it's okay. Now I can move safely to the code. Okay, now what next? The sound controller. So I think we are good to go with our HTML. Now let's move. Okay, let's move to the oh wait, give me a moment. No, do not do it this way. So maybe I'm just gonna delete this first and command this first, and let's maybe we can at first try to implement the sound as a sound. So this is an entity that we can directly use inside our A-frame scene. Okay, I need to turn on the live share. Okay, live server. Okay, over here. Something wrong. It doesn't sound. It didn't give any sound at all. Let me refresh that. Can you hear the sound? I don't think, yeah. Maybe there's some problem in here. Okay, maybe I'm just gonna skip the demonstration. I was just gonna put the code in here and explain it to you. This is actually the way we play the sound inside our application as a global. Maybe you would like to have some background music, you can use this. But if the case you want to have some sound that is triggered by some actions, then you may need to set that entity as a speaker. Okay, and apply some sound sound components inside of the entity, something like this. Oh, of course it doesn't give us any sound because it doesn't. We do not is it kalimba or what was that? The cartoon, right? Okay. Because my Firefox cannot play the MP3, that is why I couldn't. Okay, maybe I'm just gonna demonstrate it once again for this one. Let's check it. Yeah. So that's the sound. Alright, so that's the sound as a background music. And now let's try to set it as a speaker. Let's set the some entity as a speaker for this. Okay, and then for example, this box is actually the box, the big box. No, this red box, and we will set these 3 small boxes as the button. As the buttons. Okay, now I will just copy and paste my A-frame over here to here. This is my snippet. So we get the speaker through the query selector, and then from this element we can simply direct to all the children of this component, okay, and then point at the sound object, okay, and trigger the play or the pause or the stop accordingly, okay. And this action is based on the click action, and we defer the action based on its ID. So we have for example in here, we haven't yet set the ID. So let's, maybe this one is play. This one is pause, and then stop. Let's try. Which one is the play? The play is the red, the pause is the yellow, the stop is the green. Okay. Play. Pause. Play. Oh, this is stop. Okay, this is play, this is pause, and resume. Okay, so it works. And the speaker is here, this red rectangular, is not box. Okay, the box, I'm sorry. Okay, so that's all about the sound. So I can just wrap this up, and let's move to the next one, the physics. We have 10 minutes left, 15 minutes left. Maybe I'm just gonna copy and paste the snippet as well for this moment, because it quite have a lot of things to cover for the physics. At first, let me explain that, let me demonstrate the current condition of this application, the initial condition, physics. Here we have a red box and a plane, and please do remember, you may notice in here, this box is flying. It's not attached to the floor. Physically, there should be no objects flying on the real life, except it's birds or airplane with some flying mechanism, but by default it should not. Okay, that's why we should apply something in real by implementing physics. The physics engine that we have in here is called a frame physics system. It's actually some physics system based on Canon.js. If you have played with the Canon.js, Canon API previously, then you should be very familiar with the way we code our physics in this case. Okay, you can check on the its GitHub to check the full documentation of how to implement this physics. And now to implement the physics on our application, then we need to set our scene. We have some components in here called physics, and in this case we can set the debug as true. Okay, by doing this, let's see whether it gives some not yet. Then we need to set specifically every object, whether it's a static or dynamic. This one should be dynamic. Dynamic. Oh, maybe we can just wait. I think, yeah, we can maybe, I'm sorry, this is not static, but static body, dynamic body, something like this. Okay, I think something like this. Wait, it is the static one, right? Let's have a look. Okay, so we have two boxes just fall from above. Okay, let me refresh it again. So two boxes, okay, and by default the bounding box, if you know that, the collider is I think is box. So if you want to apply, for example, let's try to make it circle, then or sphere, then we may need to specify it in here. Give some attributes. Okay, shape sphere. Okay, then as you can see in here, it will roll and roll until I'm not sure. Maybe I think it's gonna be gone because, yeah, this is the end of the word and you will fall out. Bye bye. Okay, so that's the default is boxes, and if you want to make it sphere is also okay. And this is the difference. If you set the debug as true, you can see the wireframe of the collider, the bounding box or the bounding sphere. But if we set it false or just remove this one, then we didn't see anything, but it will behave like sphere. Okay. Okay, so that's the first physics that we may apply. Then maybe I'm just gonna create another demonstration. So let's do it this way. So I have a component called box generator. Okay, and I will just copy and paste this code from somewhere. You can just also copy and paste from my environment, and then set this one as the box generator. Box generator. I am sorry, without dash. Box generator. Yes. Okay. Refresh it. Wait. Something wrong. Wait. Static body. This is a sphere. If I press on this box, I will generate a new box. Okay, this is the way we generate new element inside the JavaScript, and set the attribute as 0.2, color is and the position is random. The shape is box, it's dynamic body. Wait, I'm not quite sure why it doesn't work. Let me refresh it again. Oh, okay. This is okay. So this is how it works. So as you can see in here, when I press this box, I can generate a new box with some physics. As you can see in here. And this box in particular does not apply any physics. As you can see, there is no physics in here. It is not static body or dynamic body. So we will not give it any physics effects at all, right? And the new boxes that we generate every time we click on the box is based on this code. And later you can also generate some new objects on your application and apply some physics just using this kind of code snippets. Okay, so this one is the simple physics, the gravity that we can apply. Gravity. I'm sorry, not here. So it's done. What time? Okay, 5 minutes left. Oh gosh, it seems that okay, I got some problem with I think my internet connection is getting troubled. Alright, and what others? And this is the second physics that we can try to apply. I will just also try to paste and copy and paste. Give me a moment. I need to go to the git bash, or maybe just I think. Guys, are you there? I'm afraid that I'm disconnected from the internet.
We can hear you, sir.
Okay, good. Thank you. Thanks for your confirmation. Right. Let me check. Okay, I think I'm good to go. Now let's move to the next one. So I'm just gonna copy and paste the next code. So suppose that I'm sorry to make it this way because we do not have enough time. Alright, so we have this configuration of objects inside our scene. We have a camera. Well, we put it a bit backward, 1.5, and a bit upward and with some cursor, and then we got some anchor in here, a box. We will demonstrate a spring mechanism in physics actually in this matter, and we will generate a yellow box. I'm sorry, this is the generator. This is the generator, and the yellow box itself will I think, yeah, we will just change the wait, give me a moment, the diamond, one more line in here. So we will apply some spring mechanism towards this anchor. So this box will be the anchor. Okay, this box will be the anchor. Let's have a check. Okay. So you can have a look at this. Is like they have some spring mechanism towards this object, and you can also apply something similar to this one. And there's also some other mechanism that you can basically just read from here and learn the spring, and then some constraint. Okay, the constraint, I think this one. So let me show you. So let me comment this and comment this out. This is the constraint, I think. Oh no, not this one. I need to put it up over here. Okay, maybe you should have a check by yourself in this documentation. I'm sorry for that because I cannot make the full demonstration for this matter. So maybe I'm just gonna upload this again. And for the last one, you can basically apply some physics on the script, and maybe I'm just gonna put in here. So later I will push it on the internet, guys. I'm sorry that my internet connection is getting slow, so maybe I'm just gonna, where is that, this one? Wow, still process. All right, it's okay. Then I will implement some other type of physics scripting, but maybe not in here. Maybe I will just create a new file and show you physics scripting. Okay, and copy and paste my code in here. Alright, so we can also put this just for illustration, and in this case we can utilize directly the Canon library, the physics library, and apply, for example, for the impulse and the force, etc. This is some demonstration. Maybe I can just later I will also upload this to the GitHub, to our repository, so you can learn it by yourself as well. And for this physics, maybe I'm just gonna physics scripting over here. So we have an object like this, and then if we want to press it, and it will have some impulse, and it bounces because this object is very heavy. I said it very heavy. Okay, etc. Okay, so you can later learn from my repository on GitHub. I promise you, I will upload it later. Okay, I think that's all for today. Before I close the session, maybe I'll just give you some maybe quick opportunity to ask question if you have any. If not, then it's a wrap. Thank you very much for your time joining this course, and please do remember that we will have another so we will replace the future meeting to the day after tomorrow's meeting by the through the guest lecture. I will inform you again, remind you again later on the Discord channel. Thank you very much, guys. Thank you for your joining this workshop. Hopefully you can benefit from it. See you. Good afternoon. Bye bye. Assalamualaikum.
Bye bye, sir. Thank you.